This will be a real quick video, just doing some more with limits and infinity. The sine of x plus 3, this one is always kind of a confusing one. You think about what it looks like, the sine function shifted up 3 units, so just like that. And there's a lot of temptation to say, well, it's -2 or 4. Well, remember, the definition of a limit is it's approaching one real number. So the answer to this one is there is none. It does not exist. Okay. Alright, let's go over here. The limit as x approaches 3. Well, 3 squared is 9, minus 3, minus 6, so 0, divided by 0. That means we need to do a little factoring on the top. So we're looking for two numbers that add up to -1, multiply to -6. How about x minus 3 and x plus 2? So we just cross that out. The x minus 3's will divide out. Now we plug in 3. 3 plus 2. The limit is 5. Remember, when it comes out to be 0 over 0, you've got more work. Do not stop just because it came out 0 over 0. Okay, let's go down here. The limit as x approaches infinity. Well, 3 divided by a really big number. This thing right here, I'm just going to put a little bracket around it. This is approaching 0. Because 3 divided by a big number is approaching 0. So 1 minus something approaching 0 is approaching 1. Finally, x approaches infinity. We see we've got the highest power, we get the same power on the top and bottom. So we use our good old pre-calc asymptote rules. Look at the highest power, the coefficients. It's just 3/5. Down here, the limit as you go towards infinity and negative infinity, well, we know what an x to the 5th looks like. X to the 5th looks something like that. So going towards infinity, okay, that limit would be infinity. Going towards negative infinity, that limit would be negative infinity. Again, just kind of tracing the graph. As you go to infinity, it'll keep going up. As you go towards negative infinity, it will keep going down. And finally, here we've got the highest power in the denominator, 2x minus 2 or 5x squared. So if you recall, the asymptote is 0. That is also the limit, and it is in both directions. Okay, so both directions would be 0. Here, find the limit of f of x as x approaches infinity. This is just, a way you can use all the rules you've learned to kind of make some really tough-looking equations easy. So if we're approaching infinity, 2 divided by a really big number is approaching 0. So I'm just going to replace that with 0 plus 1. And here, in the next parentheses, we've got the same power on top and bottom, 5x squared minus 1 over x squared. Put a little 1 there. And then we do our trick where we just use the coefficients since it's the same power on top and bottom. So the limit of that is 5. So we end up with 1 multiplied by 5. The limit is just 5. Okay, let's look down at this bottom one. The cosine of 1 over infinity, well, 1 over a really big number, this is approaching 0. Okay, I'm just going to write like that, 0. The cosine of 0 is 1. 1. Okay. On the bottom, 1 over x is approaching 0. So 1 plus 0 is 1. So 1 over 1, the limit is 1.